Good morning, all. Am I audible? Guys, do let me know in the comment section. நான் பேசுறது கேக்குதா? Shall we start the session? Yes, Kananga Savita. Fine. Okay, chalo. Let us start the session. I think in the last class, I had given one small homework question. I have requested you all to calculate the average power delivered by the impedance, right? Something 4 minus J3. How many of you got the answer for that question? What is the answer? I have given the current also, right? This is the question. Z equal to 4 minus J3 ohm, where I of t equal to 5 cos of 100 pi t plus 100 ampere. The average power delivered to an impedance is dash. That is the question. What is the answer for this question? Drop the answer in the comment section. See, AC analysis is also very easy chapter only, but one thing what you have to keep in your mind is you should be very careful while calculating rectangular parameters and polar parameters. Of course, it is very easy. I taught you how to convert the value from rectangular domain to polar domain to rectangular domain. But whatever the things I taught you, like in AC we have to calculate XL and XC. You should not go with the L and C parameter when we are dealing with the inductor and the capacitor. Like that, some small terms I taught you, basics, they are very important. If you don't remember those basics, it will affect you. So be careful while calculating the values. And one more thing is, in the question they mentioned that average power delivered to an impedance is dash. That is the question, right? Now I'm just asking you, what is the meaning of average power? Keep smile in your face, don't be serious. Tell me, I told you, what is the meaning of average power? Average power. Next, what I told, true power. Next, active power. Next, real power, watt power. All are who? All are simply called P only. Am I right? Yes, sir. Good. Chitra Devi, Kanaga, Savita, Sugumari, 5062.5. Check panilama. So basically, and I also told P average in AC. P average means it is what? P RMS power only, basically. So this formula, it should be equal to, either you can write IRMS square into R. See, I am writing it as P, real power. If you observe the circuit, why I am writing IRMS square into R? If you observe the circuit, the question is the average power delivered to an impedance is dash. If you observe, there is only one impedance is given. In that impedance, there are two parts. One is called a real part and another one is called imaginary part. Now tell me whether this average power will be consumed by this 4 ohm resistor or this minus 3 ohm reactance or the total impedance. Which part of the impedance will consume this average power? Sir, I only told that the average power is nothing but true power. True power means this power will be consumed by whom? Resistor only. That's why I am putting R here. Or else you can also use VRMS square upon R. Fine, sir. But here in our question, it is already given that the current flowing through the circuit is 5 times of cos 100 pi t plus 100. What we need, this is the current. But if you observe, this current is called instantaneous current. What we need RMS current. How to calculate the RMS current from instantaneous current? From the instantaneous current, the available information is maximum current will be always available. So in the data, it is clearly given that the value of maximum current will be equal to 5 ampere. From this, How to calculate the RMS current? Value of RMS current equal to maximum current divided by square root of 2. So which will it will be equal to 5 upon root 2. Now substitute this value into this expression such that we can say the average power will be equal to 5 upon square root of 2 whole power 2 into resistance value is 4. So it will be equal to 5 square will be 25 divided by root 2 whole power 2. Root 2 can be written as 2 power 1 by 2, that is root 2. Whole square means square 1 by 2, both get cancelled into 4. If you observe carefully, it will become 25 into 4 upon 2. So twice of 2 will be 4. 25 times of 2 will be 50 watts. So what is the correct answer? The correct answer is 50 watts. I hope you all have understood this. Fine, sir. Now let us moving on to the next question. 1 minute. Yes. Now the given question is, I am trying the question first. Given it is, there is one beautiful AC source. That source is connected with a resistor. Then it is again connected with an inductor. Then it is again connected with one more inductor. Then it is again connected with one more capacitor. In between here it is connected with one more inductor. Okay, sir. This is the given circuit now. See what's happening here. 1 minute. This is given and they told this value is C and this value is J5 ohm and this value is J5 ohm. This value is J5 ohm. This value is 10 ohm. This voltage value is 10 voltage. Here the value of omega, angular frequency, is 5K, 5000 radian per second. Everything is clearly given. Now what is the question? In the given circuit, data is, in the given circuit, the value of the capacitor is dash when the current I. So they are telling that there is one current I. Now we have to identify the value of C when the value of current will become 0 ampere. That's all. Now you can take 2 to 3 minutes for this question. Drop your answer in the comment section. Do it fast. You understand the question, huh? Remember, inductive reactance is given. This is not inductance value. If inductance value is given, then it will be represented as 5 Henry. Given it is J5 ohm. It means what? Inductance already converted into inductive reactance. You no need to do anything. It is already reactance only. Okay, just proceed further. Apply your common sense always. Because you know the basic. Current equal to 0 ampere. Only focus on this point. When current will become 0 in the circuit. Okay, think. Spend your time. Try to bring the answer. Drop it in the comment section. I am waiting for your answer. Keep smile. Just be relaxed. Face happy. May terrify our caring. I am repeating again. Because it's a small thing only. But நமக்கு நம்ம சீரியஸாக இருந்தால் என்ன நடக்கும்னு தெரியும்ல. நம்ம சின்ன வயசுலேருந்து அப்படி பழகிருக்கோம். It's a kind of emotional activity. It will affect our preparation. Change it first. Be happy. Got the answer? Drop it in the comment section immediately if you got the answer. Kanaga Savita, 0. 0 farad, ma'am. Good. Any other answer? I don't know. We have to solve now. Hmm. Got it? What about remaining people? Kanaga Savita. Hmm. I hope other people are trying. Classes streamlined இருக்கும்போது just be travel along with me. Delay provide பண்ணீங்கன்னா it will not be helpful. Okay, do remember this. Chalo, let us start. Okay, I hope I have given sufficient time. So actually, basically, what you have to think here is, let me tell you, what my mind is thinking is, mm, okay, I'm just thinking about this current. This current will become 0 ampere. Correct, na? Rajesh, 0.008 farad. Good. I don't know. Let us check. Okay, na? So current is 0 ampere, they told. See, when we are discussing about DC analysis, many times I would have talked about this 0 ampere current. When current will become 0? In case of DC circuits, basically we will be dealing with the resistance. If resistance is approaching infinity, immediately current will become 0 since they are reciprocal to each other. When we are entering into AC analysis, same case, current will become 0 ampere only when the value of impedance will be approaching to infinity, because in AC, I can be written as V upon Z, whereas Z will be the combination of total real part of the circuit plus J times of total imaginary part of the circuit. This total part will be approaching to infinity. When it is approaching infinity, that is the point when the value where the value of current will become 0 ampere. Am I right? Exactly, sir. This is 100% true. So what we have to do is, from this I clearly understand that the impedance offered by the network, somewhere it is going to be infinity. Okay, let us see. This current is coming here, coming here, coming here. When this current will going to be 0 ampere, if and only if these two branches, there are two parallel branches, right? Yes. Now, if you calculate the total impedance offered by this network, total impedance or total admittance, see, both are connected in parallel first. Yes, sir. And one more thing, let me tell you. When impedance is approaching to infinity, what about the admittance? We know admittance Y is equal to 1 upon Z. Since impedance will going to be approaching infinity, admittance will be approaching 0 mho. Mho is the reciprocal unit of ohm. You all know that. Fine, sir. Now, from this what I understand is the current consumed by these two branches, or I can say the admittance offered by this whole branch will going to be equal to 0. That's why they are not consuming any current. That's why here the current will become 0 ampere. When this current will going to be 0 here, it could be possible only this total admittance will become, this total parallel branch of admittance will become 0, or the impedance will become infinity. Okay, how will you write the admittance? First of all, admittance can be written as, let us take the first branch, reactance is given as what? J5 omega. Am I right, sir? Yes. So basically that is XL, that can be written as J omega L. But we are going to write admittance means இதோட reciprocal என்ன? Inductive susceptance. So we need to write inductive susceptance, that is reciprocal of this value, plus second branch admittance. In the second branch, totally we are having J times of 5 plus 1 by J times of omega C. Both are connected in series, that is inductive reactance J omega L plus 1 upon J omega C. It can be written like this. So the total value, right, I will substitute directly. I am writing it here. Sorry, we cannot write like this. This total value is impedance offered by the series C. Series impedance offered by this branch. அப்போ இதோட admittance எவ்வளோ வரும்? Just to take the reciprocal, that is the, let me call Z1. Reciprocal எடுத்தீங்கன்னா you will get Y1 equal to 1 by Z1. So the total admittance offered by these two parallel branches can be written as 1 upon J omega L plus 1 upon J omega L plus 1 by J omega C. You can write it in, like, write it in this way. Okay, sir, that is fine. Next, if you observe, if I will bring this J to the numerator, it will become minus J. So minus J by omega L plus, if you observe here, what we can do is 1 by J, we can keep right the J omega L minus J by omega C. Can I write like this? Yes. Let us go to the next page. Minus J upon omega L plus 1 upon J omega L minus J upon omega C. Take J outside from here. இதை விட ஷார்ட்டாகவும் நீங்கள் சால்வ் பண்ணலாம். உங்களுக்கு புரியணுன்றதுக்காக நான் தெளிவாக ஆக்சுவல் பேசிக் ப்ரொசீஜரில் போயிட்டுருக்கேன். ஜேவை காமனாக வெளியே எடுத்து நியூமரேட்டருக்கு பாஸ் பண்ணிங்கன்னா அதுவும் என்னவா மாறிடும்? மைனஸ் ஜேவாக மாறிடும். டினாமினேட்டரில் யூ வில் ஹவ் ஒன்லி ஒமேகா எல் மைனஸ் 1 by omega C. Fine, sir. You know this is the total admittance. அப்போ இந்த total admittance value என்ன வரும்? This is going to be 0 mho. Why it is 0? They only told, I did not told. Correct தானே? If you want to make the value of current as 0 ampere, current can be written in two ways. You can write like this. I is equal to V by Z, or we can write V into Y, because Z can be replaced by 1 by Z can be replaced by admittance Y. So they are telling that this current is approaching 0. It means the value of admittance will become 0, because voltage cannot be 0. See, they told they have this circuit is having certain amount of voltage. We cannot make it 0. So this admittance is approaching 0. So if I will equate it to 0, then I can write like this: minus J upon omega L minus J upon omega L minus 1 by omega C equal to 0. So in the next step, minus J upon omega L equal to, I am just passing this term to the right side. So this can be written as J plus J omega L minus 1 by omega C. So J will be cancelling out. So can I write like this: 1 by omega L minus 1 by omega L. In the denominator, take minus outside. If we take minus outside, it will become minus of omega, 1 upon omega C minus omega L. So this minus minus will be cancelling out. So anyway, if I will equate LHS and RHS, I am just passing this one to the left side, I am passing this one to the right side. So this can be written as 1 upon omega C minus omega L equal to omega L. If you pass this minus omega L to the right side, 1 upon omega C equal to 2 times of omega L. So let us reduce this expression further. So it can be further written as, see, if you observe, I am having 1 by omega C equal to 2 times of omega L. So pass this omega to the left hand side, right side. 1 by C equal to 2 into omega power 2 into L. If I will take the reciprocal on both sides, C is equal to 1 upon twice of omega power 2 into L. So from this, 1 by 2 into, what is the value of omega? Omega 5k they told, right? So it means 5000 square into the value of L is how much? No, we don't know the value of L, right? Basically we know only omega L. All the omega L is only 5 ohm, because they only told all are same value. Let me do one thing here. I cannot directly write like this. So C is equal to, let me write like this: 2 times of omega L into omega. Can I break like this? Instead of writing omega square L, because I know the value of magnitude of the omega L is 5. So 2 times of 5 will be 10. Further, at last, this can be written as C is equal to 1 upon 2 times of 5 will be 10. 10 into, what is the value of omega? 5k. 5k means 5000. So this can be finally written as 5 into 10 power 4. Or we can write 0.2 into 10 power minus 4. Or we can write it as, see how I am writing this one. Carefully observe this. 0.2 into, I am multiplying it by 10 power 2 and I am dividing it by 10 power 2 into 10 power minus 4. Now if you observe, or otherwise we can also write like this: 0.2 into, see there, if I will bring this 10 power 2 to the numerator, what will happen? 10 power 2 into 10 power minus 2. When we are bringing it to the numerator, sign will change. So 10 power minus 2 into 10 power minus 4 will become 10 power minus 6. 10 power minus 6 will be equivalent to micro. Okay, sir. So minus, okay, 0.2 into 10 power 2 will become 20. So 20 into 10 power minus 6. 10 power minus 6 means micro. Unit of the capacitor is farad. So this can be written as 20 microfarad. Am I right? Did I do any mistake here? You can just cross check, because I am also not sure. But what we got, our answer is 20 microfarad. This is how we are approaching the question. Okay. So you have to apply your common sense. இந்த இடத்துல clear-ஆ நமக்கு கொடுத்த clue என்ன அப்படின்னா, கரண்டோட வேல்யூ வந்து 0 ஆகுதுன்னு அர்த்தம். அப்போ இந்த பிரான்ச்ல இருந்து வர கரண்ட் வந்து எப்போ 0 ஆகும் அப்படின்னா, இந்த parallel branches-ஓட admittance value 0 ஆகணும். அப்படி இல்லைன்னா மொத்த impedance வந்து எவ்வளோ வரணும்? Infinity. So basically, why I have done like this? If you observe, there are 3 branches like this. இந்த பிரான்ச்ல இருந்து வர கரண்ட் வந்து 0 ஆம்பியர் வருது அப்படின்னா, current consumed by this branch and this branch is going to be what? According to KCL, this total current, I cannot individually define that this current will be 0, this current will be 0. I cannot define like this. Why? Because the net current only will becoming 0 here. It means current consumed by this branch is I1. I am calling this current is I2. Now I can say total current coming from the supply equal to current consumed by the loads. These two parallel branches. This is the correct observation. So from this what I can say, about total supply current 0 ஆகுது அப்படினா addition of the current consumed by these two parallel branches will become 0. Upper total, this I1 plus I2 is nothing but the current consumed by the parallel branches. And the total current வந்து 0 ஆகணும் அப்படினா the total admittance offered by those two branches will become 0, or the total impedance offered by those two branches will be approaching infinity. Are you getting me? So that's why I have taken these two parallel branches and I have approached in this way. We got the answer, right? Fine, sir. Now let us drop the next question. See the beauty of questions. Slowly spend your time to understand the questions. There is one capacitor and this is not inductor. Then what is this? நீங்களே சொல்லுங்க. What is this? This is called transformer. Now I am keeping the inductance here. Yes. Again there is one more transformer. Okay, it will be like this. Again it is connected with a resistor. This is the given circuit. This capacitor value is 10 microfarad. This inductance value is 1 millihenry. This resistance value is 2.5 ohm. Now this is the point where they are trying to calculate the total impedance from these two terminals. Question is, find the transformer ratio. They are defining this ratio is 1:B. This ratio is 1:A. So find the transformer ratio A and B such that the impedance is at N. See, you are requested to calculate the value of A and B such that the value of the net impedance Z in equal to 2.5 ohm when the network is excited with the sine wave voltage. Angular frequency omega is given when the circuit is excited by a AC supply voltage with the angular frequency of 5k radian per second or 5000 radian per second. That is the given data. Now you are supposed to calculate the value of A and B. Find the value of A and B, drop it in the comment section. Take your time. உங்களுக்கு first question புரிஞ்சதா? இது transformer. Transformerக்கு primary, secondary ரெண்டு side இருக்கும். அதுக்கு ஒரு turns ratio யூஸ்வலா நம்ம என்ன பண்ணுவோம்? Define பண்ணுவோம். Right? Fine, sir. This is called a transformer ratio. அடுத்து என்ன பண்ணிருக்காங்கன்னா total impedance வந்து from the input portல இருந்து calculate பண்றாங்க. இந்த மொத்தமா total impedance அப்படிங்கிறது டிரான்ஸ்ஃபார்மர்ல நம்ம என்ன பண்ணுவோம், செகண்டரியில் இருக்க இம்பிடன்ஸை பிரைமரிக்கு மாற்ற முடியும், பிரைமரியில் இருக்க இம்பிடன்ஸை செகண்டரிக்கு மாற்ற முடியும். அந்த மாதிரி கன்வெர்ட் பண்ணும்போது என்ன இருக்கு அப்படின்னா மொத்தமாக இந்த இண்டக்டன்ஸ், கெப்பாசிட்டன்ஸ், ரெசிஸ்டன்ஸ் எல்லாமே சேர்ந்து மொத்தமாக எவ்வளோ வந்திருக்கு அப்படின்னா 2.5 ohm வந்திருக்கு. இது வந்து எந்த ஃப்ரீக்வன்சியில் அப்படின்னா 5000 radian per secondல. இந்த கண்டிஷன்ஸை வச்சுக்கிட்டோம், இந்த டேட்டா வச்சுக்கிட்டு ஃபைண்ட் தி வேல்யூ ஆஃப் A and B. தட் இஸ் தி கிவன். ப்ரொசீட் ஃபர்தர். Okay, let me tell you. Some of you may be little bit weak in the calculation of transformer primary to secondary conversion. Impedance வந்து primaryல இருந்து செகண்டரிக்கோ இல்ல செகண்டரில இருந்து primaryக்கோ எப்படி கன்வெர்ட் பண்றது அப்படிங்கிறதுல some of you may be little bit weak. For them I am just telling you a small thing. Listen, let us take a transformer and assume this transformer will be having two sides. One is primary and another one is secondary. Keep smile in your face. Let us take the impedance available at the secondary side is, let us take, we are calling it as Z2, and the number of turns in the primary is N1, number of turns in the secondary is N2. How to transform this impedance from primary to secondary? Suppose I am calculating equivalent impedance from here, Zn, and there is one more impedance connected here, that is called Z1. Let us take like this. Now how to calculate the total impedance? For that, first step is transfer this impedance from secondary to primary. How do I do that one, sir? That is very simple. In order to do that, we are calling it as Z2 dash. During the conversion, I am just putting new name. It is transferred from secondary to primary. It should be equal to Z2 upon number of turns in the secondary divided by number of turns in the primary whole power 2. This formula you have to use when you are transferring the impedance from secondary to primary. Suppose, no sir, I am transferring in, I am keeping Z2 there itself, but I would like to transfer this Z1 to the secondary. What should I do? If you are transferring the impedance from primary to secondary side, we are calling it as Z1 dash. It will be equal to actual impedance into number of turns in the secondary divided by number of turns in the primary whole power 2. So here it should be in division, here it should be in multiplication. That is how we are transferring the impedance from primary to secondary and secondary to primary in case of transformer. We will have a proper proof for this. This is not a kind of things to memorize, but as of now we are in network theory basics. So this is also basic only, that's why I am solving these kind of questions here itself. Slowly when we are entering into transformer, you may be remembering these small things. That is sufficient because nobody will going to ask you to derive this. Okay. So if you know how to transfer the impedance, that is enough. You can solve this question. Now I had given the sufficient data. Proceed further. Apply your common sense. I am repeating again. Take 2 to 3 minutes. Try to solve and bring the answer. A beautiful clue is given that the value of Zn equal to 2.5 ohm only. Remember that. Phase angle லாம் எதுவுமே கொடுக்கல, just அது 2.5 ohm மட்டும்தான் வரும்னு சொல்லியிருக்காங்க. அந்த இம்பிடன்ஸ்க்கு மேக்னிடியூட் மட்டும்தான் கொடுத்துருக்காங்களா, ஃபேஸ் ஆங்கிள் கொடுக்கலையா அப்படின்லாம் யோசிச்சு பார்க்காதீங்க. அவங்க சொல்லியிருக்கிறது மொத்தமாக இந்த சர்க்கியூட்டோட டோட்டல் இம்பிடன்ஸு 2.5 ஓம் தான் வருது அப்படின்னா அங்கே ரியல் பேராமீட்டர் மட்டும்தான் எக்ஸிஸ்ட் ஆயிருக்குன்னு அர்த்தம். இமேஜினரி பேராமீட்டர்லாம் 0 ஆயிருக்கு. இந்த கொஷின் ஏன் இங்கே வந்திருக்கு தெரியுமா? இட்ஸ் அ கைண்ட் ஆஃப் சேம் மாடல். ப்ரீவியஸ் கொஷின் சால்வ் பண்ணோம்ல, அதே மாடல் கிட்டத்தட்ட. Anybody got the answer? ட்ரை பண்ணுங்க. Keep smile in your face. Just try and drop your answer in the comment section. Okay, your time is over. Let me try to solve this question. Okay, கவனிங்க. ஆக்சுவலாக இந்த இம்பிடன்ஸை வந்து நம்ம ட்ரான்ஸ்ஃபார்ம் பண்ணும்போது பேசிக்கலி சப்போஸ் லெட்டஸ் டேக் இப்போ இந்த தேர்ஸ்டரி வெண்டிங் எடுத்துக்கிட்டிங்கன்னா இங்கே வந்து ஒரு 2-3 பேர் இருக்காங்க அப்படின்னா நம்ம பேசிக்காக எப்படி சார் ட்ரான்ஸ்ஃபர் பண்ணிக்கலாம். You can do any type of transfer in case of transformer. Like first you can transform this inductance here directly. After that slowly you can transform this resistor from here to here and then from here to here. Or you can first transform this resistor from here to here. After that you can calculate this value addition of this total, this inductance plus resistance. Then you can transform the total into the primary. These choices are completely up to you. You can do any convenient one which will be suitable for you. Let me think in this way. I would like to do in simple way. I don't want to make it anything difficult for me. So in my think, what my mind is telling is, don't do over things at all. They clearly told that the value of impedance is defined as is at n equal to 2.5 ohm. I'm just focusing into this value. What it's clearly indicate. Basically, impedance can be written in this form. It will be the combination of real part plus j times of imaginary part in terms of ohm like this. But if you observe in this expression, is there any j term? No sir. So it is clearly indicate here we have only real term. Yes or no? Real term, okay sir. Plus then where is imaginary term? Imaginary term will be 0 ohm. Am I right? So it is clearly indicating that the value of imaginary part of the impedance is approaching to 0 ohm. Am I right sir? Exactly. That's why real part will be simply equal to what? 2.5 ohm. They only told that. Sky Star, Ratika, A equal to 2, B equal to 0.5. Very good. Let us see. I am not sure. So imaginary part equal to 0. We understand this. Fine sir. Now see there, given it is inductance, but we are in AC analysis. What shall we do? First calculate the inductive reactance J omega L. J, what is L of omega? Omega is given as 5000 into the value of inductance is 1 into 10 power minus 3. So see there, these 0 can be written as 10 power plus 3, 5 into 10 power plus 3. 10 power plus 3 into 10 power minus 3 will become 10 power 0, or we can say 1. So it will be equal to J5 ohm. Similarly, if we calculate capacitive reactance, either it can be written as minus J by omega C or 1 by J omega C. So minus J upon omega value, once again 5000 into 10 microfarad. Micro means 10 power minus 6. See there. 30 plus 10, 10 power 4 into 10 power minus 6 will be equal to 10 power 4 into 10 power minus 6 will be equal to 10 power minus 2. If I will bring this 10 power minus 2 to the numerator, it will become plus 10 power 2. So I can write minus j by 5 into 10 power 2. 1 by 5 can be written as 0.2 minus j 0.2 into 10 power 2. 10 power 2 into 0.2 will become 20. So this can be written as completely. It will be equal to minus 20j. So finally what we have understand, this capacitor reactance is minus 20j. This inductive reactance is equal to J5, right? J5 only now. Yes, it is J5. Okay, now I would like to simply transfer. I will think about this resistor later. First I will transfer this reactance from here to here, and then slowly I am transferring this resistor from here to here, then from here to here. I am going to individually transfer from here to here. First inductive reactance. Whenever we are transferring some impedance from secondary to primary, the number of turns is clearly defined for the first transformer. See, the first transformer is having two sides. Primary side, then this is called secondary side. Then they told primary side is 1, secondary side is B. Correct now? 1 is to B. Right. So the secondary side what I am having is the impedance J omega L, or we can write now J5 ohm. How will you transform it to the primary side? It can be written as secondary to primary J5 divided by This is n1, this is n2. n2 divided by n1 whole square. So this can be written as j times of 5 divided by b square. This is imaginary part. If you observe, this is imaginary part. It will be connected in series with the primary term. Already in the primary we have a capacitor. Now this inductance has been transformed to the primary, and this value is j times of 5 upon b square. And the capacitor value already we calculated that minus j times of 20. Both are connected in series. But in our circuit, if you observe, while calculating the impedance, we are going to have only real part of the circuit. If you observe in this circuit, only two imaginary part. One is capacitor, another one is inductor. Only two imaginary part. This is completely real part. So this real part will not going to be equal to 0. But now I brought the total imaginary part. இங்க வந்திருக்கிறது total imaginary part. இவ்வளவுதான் இருக்கு சர்க்யூட்ல. This imaginary part will going to be what? It will be going to be equal to 0, sir. So I can write like this now. Minus j times of 20 capacitor value plus j times of 5 upon b square. Inductive value will be equal to 0. Imaginary part will be 0, na? So if you reduce this, what you will get? Minus j times of 20 equal to minus j times of 5 upon b power 2. Minus j will be cancelled. 4 times of 5 will be 20. So from this I can write that 4 equal to 1 by b power 2, or we can say b square equal to 1 by 4, b is equal to plus or minus 1 by 2. But transformer turns ratio, we are talking about the values of a and b. We are calling it as turns. Number of turns should be positive, na? Like இதுல எத்தனை turns இருக்கு? 2 turn 3 turn அந்த மாதிரி இருக்குறது நம்ம நெகட்டிவ்ல சொல்ல முடியாது. -3 turns இருக்கு, -10 turns இருக்குன்னு உங்களால டிஃபைன் பண்ண முடியுமா? No. It should be positive. So I am considering only positive value. It should be equal to 0.5. So I got the value for b. The value of b is 0.5. Keep it in your mind. Okay. Now in the same fashion, let us transform the resistor. If you observe, first we have to transform the resistor from third transformer to second transformer. Then we will transform the resistor from second transformer to primary transformer. Right? The primary side of the transformer. Okay, sir. First, what I am going to do is, let us take second transformer. Let us take, focus on this. Here we have 2.5 ohm resistor. Here the turns ratio is 1:8. Am I right? Yes, this is 1:8. Let us transform it. How will you transform from here to here? Here to here, it can be written as 2.5 divided by, once again, n2 is n1 is 1. n2 by n1, that is a by 1 whole square, So this can be written as 2.5 by a square. This is the resistance that is available now at this port, this junction. Now again we have to transform this from secondary side to primary side of the first transformer. How will you do that? For that, let us take, now there is one more transformer that is also having primary, secondary. Now the resistance is placed at this position. This transformer ratio is 1:b. This is a square, sorry. If you are transforming from here to here, what will happen? Once again, resistance value is 2.5 divided by a square whole divided by n2 by n1 whole square. n2 value is b by 1 whole square. Finally, this can be written as 2.5 upon a square into b square. Can I write like this? Yes, sir. This is the total real part of the circuit. Is there any other real part? No. This total real part is equal to Z equivalent. Z in value is equal to 2.5. This will be equal to 2.5 upon a square into b square. அவங்க தானே சொல்லியிருந்தாங்க total real part plus imaginary part வந்து 0. கொஸ்டின்ல கொடுத்திருக்க டேட்டா வச்சு நான் ஏற்கனவே சொல்லிட்டேன் imaginary part 0 ஆயிருக்குன்ட்டு. அப்ப total real part equal to எவ்வளோ? கொடுத்திருக்க total value 2.5 getting cancelled. From this I can say a square into b square equal to 1. Yes, sir. A square into, what is the value of b square? We know the value of b square equal to 1 by 4. So let me substitute it. 1 by 4 equal to 1. So from this I can say a square by 4 equal to 1, or I can say a square equal to 4, or I can say a is equal to plus or minus square root of 4, or I can say a is equal to plus or minus 2. But minus should not be the answer, plus only the answer, because number of turns. So the value of a equal to 2 and the value of b equal to 0.5. See how beautifully they are making the question with the help of AC circuits. It is very simple circuit now, but you should apply your common sense. That is very important here. Common sense should be required in the circuit. Okay, chalo. Let me drop you one more question here. At least I am expecting the answer from your end for this question. It's the same kind of transformer question only. நான் தான் சொன்னேன்ல, நீங்கள் பேசிக்ஸ் அண்டர்ஸ்டாண்ட் பண்ணிக்கிட்டீங்கன்னா machines also will become very easy. This is inductance. எப்பயுமே வந்து இந்த மாதிரி இண்டக்டன்ஸ் வரைஞ்சிட்டு அது கூட பார் போட்டாங்கன்னா அது டிரான்ஸ்ஃபார்மராக கன்வெர்ட் ஆகிடும். டூ ரிமெம்பர் திஸ். Just to understand the basics now. Later we will slowly solve so many problems. There is one capacitor. Now the values are given. This is 40 kilo ohm. Just magnitude மட்டும் கொடுத்திருக்காங்க. நம்ம இதை ஆக்சுவலாக எப்படி எழுதணும் அப்படிங்கிறது நமக்கு தெரியும். அந்த மாதிரி நீங்கள் எழுதிக்கலாம். அடுத்தது ரெசிஸ்டரோட வேல்யூ வந்து 80 கிலோ ஓம். இது வந்து 10 ஓம்னு மட்டும் கொடுத்துருக்காங்க. இங்கேருந்து போகிற கரண்டோட வேல்யூ வந்து I. சப்ளை வோல்டேஜ் வந்து 100 வோல்ட்ஸ். இந்த மாதிரி கொடுத்துருந்தாங்கன்னா அது என்னது? தட் இஸ் கால்ட் ஆர்எம்எஸ் வோல்டேஜ், ரைட்? இப்போ கொஸ்டின் என்னன்னா, இந்த டிரான்ஸ்ஃபார்மரோட பிரைமரி டு செகண்டரி டர்ன்ஸ் வந்து 1:100. ஃப்ரீக்வன்சி வந்து எஃப்ல கொடுத்துருக்காங்க. இதுக்கு முன்னாடியெல்லாம் ஆங்குலர் ஃப்ரீக்வன்சி கொடுப்பாங்க, இப்போ எஃப்ஏ கொடுத்துருக்காங்க டைரெக்டாக. Now the question is, in the following circuit shown, the connection of an ideal transformer with the primary secondary turns ratio is 1:100. Primary secondary turns கொடுத்துட்டாங்களா? The applied voltage is 100 voltage and 50 Hz frequency. The RMS value of the current I in ampere is dash. Questionல currentோட வேல்யூ வந்து என்னன்னு கேட்டிருக்காங்க. Take 3 to 4 minutes also. Try to solve the answer as fast as possible. First time இதை சால்வ் பண்ணுறவங்களுக்கு தான் 3 to 4 minutes. ஆல்ரெடி சால்வ் பண்ணி டிரான்ஸ்ஃபார்மரை பற்றி தெரிஞ்சவங்களுக்கு 1 to 2 minutes sufficient. Do it fast. டிரான்ஸ்ஃபார்மரோட இம்பிடன்ஸை செகண்டரிலேருந்து பிரைமரிக்கு எப்படி மாற்றணும் அப்படிங்கிறத நான் சொல்லி கொடுத்துட்டேன். இப்போ தான் நம்ம சால்வ் பண்ணோம். தட் இஸ் எனஃப். டோட்டல் கரண்ட் வந்து ஒரு சோர்ஸ் வந்து சப்ளை பண்ணுறதை கண்டுபிடிக்கணும் அப்படின்னா என்ன பண்ணணும்? டோட்டல் வோல்டேஜ் டிவைடட் பை டோட்டல் இம்பிடன்ஸ். கேல்சி தேவைப்பட்டால் நீங்கள் யூஸ் பண்ணிக்கலாம். ட்ராப் யூர் ஆன்சர். டூ இட் ஃபாஸ்ட். Anyone got the answer? 2 minutes வந்து ரொம்ப மேக்ஸிமம் டைம். உங்களுக்கு பேசிக்ஸ் இப்போ நான் சொன்னது உங்களுக்கு புரிஞ்சிருக்கும். கெப்பாசிட்டிவ் ரியாக்டன்ஸை எப்படி எழுதணும்னு தெரியும், இண்டக்டிவ் ரியாக்டன்ஸை எப்படி எழுதணும்னு தெரியும். அவங்க எப்படி கொடுத்துருந்தா என்ன, உங்களுக்கு எப்படி எழுதணும்னு தெரியுமா தெரியாது, அதுதான் உங்களுக்கு தேவை. சார் அவங்க அப்படி கொடுத்துருக்காங்க சார், இந்த கொஷனில் நீங்கள் யார்ட்டையும் சொல்லக்கூடாது. ஃபண்டமெண்டல் பேசிக்ஸை நீங்கள் தெளிவாக இருக்கீங்களா இல்லைன்றது தான் எக்ஸாம் கண்டக்ட் பண்ணுறது. நீங்கள் அவங்க எப்படி அப்படி கொடுக்கலான்ற கொஷினை நம்ம ரைஸ் பண்ண முடியாது. ஸோ பேசிக்கலி கெப்பாசிட்டிவ் ரியாக்டன்ஸ்னால் இப்படி தான் சார் எழுதணும், அதே மாதிரி எழுதுங்க. இண்டக்டிவ் ரியாக்டன்ஸ்னால் இப்படி தான் சார் எழுதணும், உங்களுக்கு தெரிஞ்ச ஃபார்மெட்டில் எழுதுங்க. அப்போ தான் ஆன்சர் கரெக்டாக வரும். அவங்க அப்படி கொடுத்துருக்காங்களே அப்போ வேறு மாதிரி ஏதாச்சும் இருக்குமான்னு சொல்லிட்டு யோசிக்கிறதுக்கு வேலையே இல்லை. உங்களுக்கு கிளியராக தெரியுதா இதுதான் அப்படின்ட்டு உங்களுக்கு தெரிஞ்சால் அப்ளை பண்ணுங்கள். ஆட்டோமேட்டிக்லி யூ வில் கெட் தி ஆன்சர். காட் தி ஆன்சர். Sugumari 4.54 ampere. Very good. Any other? Any other answer? What other people are doing? ட்ரை பண்ணி வர ஆன்சரை போடுங்க. ரொம்ப சிம்பிள் தானே. சரி, fine. I think I have given sufficient time to you all. இப்போ நான் சால்வ் பண்ணுறேன், கவனிங்க. My mind is blowing with this capacitor reactance first. அவங்க ஃபர்ஸ்ட் இதை 40 கிலோம்னு கொடுத்த உடனே இந்த மாதிரி இதை எழுதக்கூடாதுன்னு என் மைண்டு சொல்லிச்சு. ஏன்னா capacitor reactance பேசிக்காக நம்ம எப்படி எழுதுவோம், மைனஸ் ஜே இன் டர்ம்ஸ் ஆஃப் மைனஸ் ஜே பை ஒமேகா சின்னு எழுதுவோம். அவங்க என்ன கொடுத்துருக்காங்க, ஒன்லி மேக்னிடியூட். ஸோ திஸ் கேன் பி ரிட்டன் அஸ் மைனஸ் ஜே டைம்ஸ் ஆஃப் 40 கிலோ ஓம், ஆர் வி கேன் சே 40,000 ஓம். Resistance is given as 80 kilo ohm or 80,000 ohm. Fine sir. Both are connected in series. அப்போ இதை நம்ம டைரெக்டாக என்ன பண்ணிக்கலாம், ஆட் பண்ணிக்கலாம். R minus J times of 40,000. R value we know 80,000. So total value can be written as 80,000 minus J 140,000. This is the total impedance available at the secondary side. Now focus on the question. Question என்ன கேட்டிருக்காங்க, current I is dash. How will you calculate the total current supplied by the source? For that we need total supply voltage divided by total impedance offered by the load. அப்போ இப்போ நம்ம சோர்ஸ்ல இருந்து நமக்கு என்ன தேவை, total impedance offered by the load தேவை. அப்போ டிரான்ஸ்ஃபார்மரோட செகண்டரி லோட்ஸை பிரைமரிக்கு டிரான்ஸ்ஃபார்ம் பண்ணிட்டு அண்ட் தென் பிரைமரியில் இருக்க லோட்ஸையும் செகண்டரியில் இருக்க லோட்ஸையும் சம் பண்ணி அந்த டோட்டல் வேல்யூவை இங்கே சப்ஸ்டியூட் பண்ணாதான் we will get the answer. Because voltage is readily available, but which is missing here? Total impedance is missing. Let us see. First we know secondary side impedance. How will you transform it to the primary side? This can be transformed from secondary to primary. Primary இது போனோம் அப்படின்னா secondary value divided by number of turns in the secondary divided by number of turns in the primary whole power 2. That is how we are transforming it to the primary side. We can call it as Z2 dash. First I am calling it as Z2. Transferred impedance will be Z2 dash. So here it can be written as 80,000 minus J times of 40,000 upon, what is L of N2 sir? N2 is 100, N1 is 1 whole power 2. 100 square will be 10,000. Now 10,000, if you divide it by 80,000 minus J times of 40,000 divided by 10,000, what will you get? See there, from the 80,000 we can take 10,000 outside, from the 40,000 we can take 10,000 outside. So 10,000 in bracket 8 minus 4J or J4 divided by 10,000. 10,000 getting cancelled. So the transferred impedance from secondary to primary is 8 minus J4. This is Z2 dash. What is the available impedance in the primary? 10 ohm. But if you focus carefully, that is inductive reactance. Inductive reactance can be written as J times of omega L, not simply omega L. J into omega L value is 10 ohm only. So the total impedance now in the primary side, the total input impedance from the source that we are observing is primary inductance plus secondary inductance. Secondary means transferred impedance from secondary to primary, J10 plus 8 minus J4. This can be further written as, real part is only 8, imaginary part J10 minus J4, it will become plus 6 times of J. That is the total impedance. Now if you observe, total current will be equal to total supply voltage divided by total load impedance. Total supply voltage is 100 at an angle of 0 degree because simply they kept only 100. So it means what? It is simply real part only. Divided by total impedance. What we observe? Real part is 8, imaginary part is 6. So 8 plus j times of 6. So it is in rectangular form. We need only magnitude, or we can convert it into polar form. How will you do that? In order to transform it into polar form, first let me write like this: 100. See, magnitude of the 100 will be 100, its correspondent phase angle will be 0 degree. You know how to transform a rectangular value to polar. If rectangular value is real, then the polar value will become simply 100 at an angle of 0 divided by, here one more rectangular value is there, 8 plus j times of 6. How will you convert it into polar? First step, calculate the magnitude of this given. Magnitude square root of real part square plus imaginary part square. While calculating the imaginary part means j represents that the given term is imaginary. Just to tell you that information, whether imaginary part is there or not, just to tell you that information, we are putting this imaginary operator. Don't square this j also while calculating the magnitude, that is wrong. And phase angle, how will you calculate the phase angle? Tan inverse of, okay, imaginary value divided by real value. If you observe, 8 square will be 64, 6 square will be 36, square root of 64 plus 36. Here let us reduce this. Tan inverse of 3 times of 2 will be 6, 4 times of 2 will be 8, 3 by 4, or I can say 0.75. Take calculate the value of tan inverse of 0.75. 64 plus 36 will be 100, square root of 100 will be 10 at an angle of tan inverse of 0.75. Anyway, நம்ம questionல magnitude மட்டும் தான் கேட்டிருக்காங்க. So I don't want to know this tan inverse value. You can calculate it by yourself. I am putting here 10 at an angle of tan inverse of 0.75. So this can be further written as 100 by 10 will be 10 ampere. In the tan inverse of 0.75 மேல கொண்டு வந்தீங்கன்னா it will be minus tan inverse of 0.75. இதை நீங்க calculate பண்ணி போட்டுக்கோங்க. I need only magnitude. In my case, answer will be 10 ampere. That's all. So that is how we are doing the calculation. See how simple your questions are. But the thing is, basic should be very strong. Fundamental basic. Rajesh, good. You got the answer already. Okay. Let us move on to the next question. The given it is, there is one supply voltage and there is one resistor and there is one coil. Coil means, you know, it is the combination of resistor plus inductance. They told that they are treating this one as the coil. Yes. And this value they are calling it as VC. Simply they are calling it as, they are putting coil voltage. VC means coil voltage. In this question, VC means coil voltage. They are calling it as VR and they are calling this one is supply voltage. Now the question is, a resistance and the coil are connected in series and supplied, and it is supplied from a single phase 100 voltage 50 Hz source. This voltage value is given 100 volt 50 Hz source. Given the RMS values of possible voltage across the resistance VR and coil VC is dash. They are asking you to calculate the RMS voltage of this VR and total coil voltage will be dash. For that they are given 4 options. Option A 65,35, option B 50,50, option C 60,90, 60,90, option D 60,80. See, this is 60, don't get confused. Resistance and coils are connected in series. Yes, this is the given data. Try to bring the answer. That is the only given data. Take your time and drop your answer. Just apply your common sense. Bring the answer. Anyone got the clue? 60, 80. Yeah? Good. Radhika. Any other? Let me check. இது வரைக்கும் நீங்கள் நான் டீச் பண்ணதை எந்த அளவுக்கு புரிஞ்சு வச்சுருக்கீங்கன்னு பார்க்குறேன். Before teaching, you guys also studying na? Drop your answer. ஒரு விஷயம் நல்லா புரிஞ்சுக்கோங்க. நடத்துகிற விஷயத்தில் கிறிஸ்டல் கிளியராக இருங்க. இமேஜினரி பார்ட்னா இதுதான், ரியல் பார்ட்னா இதுதான். இண்டக்டிவ் ரியாக்டர்ஸ்னால் இப்படி தான் எழுதணும், கெப்பாசிட்டிவ் ரியாக்டர்ஸ்னால் இப்படி மட்டும்தான் எழுதணும். நானே இதை மாற்றி சொன்னால் கூட நோ சார், இதுதான் நான் படித்த பேசிக், நான் ஆல்ரெடி ப்ராப்ளம்னா சால்வ் பண்ணி பார்த்துருக்கேன், எனக்கு கரெக்டாக ஆன்சர் வந்திருக்கு, திஸ் இஸ் தி ஃபண்டமெண்டல் பேசிக், யுவர் வே இஸ் ராங், லைக் தட் யூ ஹவ் டு டெல். பேஸ் அவ்வளோ ஸ்ட்ராங்காக இருக்கணும். நீங்கள் நத்திங் இஸ் தேர், ஃபண்டமெண்டல் பேசிக்ஸ் நீங்கள் லேர்ன் பண்ணுறதை ஃபிக்ஸ் பண்ணிக்கோங்க, இதுதான் கரெக்ட், அவ்வளோதான். அதுக்கப்புறம் வேற எங்கேயாச்சும் ஒரு இடத்த பார்க்கும்போது ஒரு இப்படி வருமோ அப்படி வருமோ, நம்ம படிச்சது தப்பாக இருக்குமோ, நீங்கள் படித்தது தப்பாக இருந்தால் அப்போ எப்படி இவ்வளோ கொஷின் சால்வ் பண்ணீங்க, அதெல்லாம் கிளியராக இருக்கணும் மைண்டில். நோ 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 நோ, இன் திஸ் கொஷின் சம்திங் இஸ் ராங், லைக் தட் யூ ஷுட் பி தேர். திங்க். Okay, got the answer. Any others? No one? Okay, let me drop the answer for this question. I'm just asking you, question என்ன கேட்டிருந்தாங்க? VR VC கேட்டிருக்காங்க சார். ட்ரூ கண்டிப்பாக ட்ரூ தான். ஃபைன், we are in AC analysis, right? Though it is VC அப்படிங்கிறது total coil voltage. How will you write VC? It can be written as, let us take, inside of this coil we have two people, one is real part, another one is imaginary part. So this can be written as voltage drop across the resistor R1. I'm just treating it as R1 because already one more real part is there now. In order to avoid the confusion, I'm putting VR1 plus coil voltage J times of voltage drop across the inductor. Am I right? This can be written as the total coil voltage. Treat this one as equation number 1. One more voltage is there, that is voltage drop across the resistor. Now, if you apply total supply voltage written as voltage drop across the resistor plus voltage drop across the second resistor plus voltage drop across the coil. Here we have to club the real part. So real part can be written as VR plus VR1 whole will become the real part. J times of VL. This is how we are writing the supply voltage. So basically supply voltage can be written in two format. One is in polar form, another one is in the rectangular form. Anyway, given it is in polar form, 100 voltage, it means simply 100 at an angle of 0 degree. That is the actual meaning of this. So from this, how will you write this expression? This expression can be written as real part VR plus only magnitude I am focusing. Real part square plus imaginary part square. We should keep all this term under root. That can be considered as the supply voltage. Am I right, sir? This is the actual truth. So they only gave that the value of supply voltage is 100 volt. So we can substitute 100, or you can also go up with the options. Option wise போனீங்க அப்படின்னா total real part you can consider it as 60, total imaginary part you can consider it as 80. But அவங்க என்ன கேட்டிருந்தாங்க, you are requested to calculate the real part of the only resistor. VC means that is the combination of another real part plus imaginary part. With this just given 100 voltage data, how can I break these two real part alone separately? It is possible. இங்க நீங்க என்ன பண்ணிக்கலாம் அப்படின்னா, this is very simple that total real part வந்து 60 இருந்தது அப்படின்னா we can say real part square plus imaginary part square root போட்டீங்கன்னா you will get the 100. Of course this is correct answer and it is valid only if the value of VR plus VR1 will be equal to 60. You should not directly write VR square plus VC square. This is wrong. Why? VC is not imaginary term. Inside of the VC we have two terms. One is real, another one is imaginary term. How can you directly do this kind of squares? This is wrong, na? I told you be careful with the basic. This question was asked by IISc Bangalore. You all know. IISc Bangalore will be located in, sorry, it is in Bangalore only. That is IISc. So I think they have given this question in the year of 2016. That year. During the result, a credit mark will be given to all the students by considering this question as wrong question. Okay. So the correct answer is none of the above. So it doesn't matter what type of question they are giving. You should be very conscious with this data. ரியல் பார்ட்டி இமேஜினரி பார்ட்டி தனித்தனியாக ஸ்கொயர் பண்ணி மேக்னிட்யூட் எடுத்தால் 100 போடலாம். அது எப்படி விஆரையும் விசி ஸ்கொயரையும் விசியும் தனித்தனியாக இதில் கொஞ்சம் ரியல் பார்ட் இருக்குது, அந்த ரியல் பார்ட்டை வந்து இமேஜினரி பார்ட்டோட கொலாப்ஸ் பண்ணிவிட்டு ஹவு கேன் யூ டூ தி calculation? That is wrong, na? Data வந்து கம்ப்ளீட்டாக கொடுக்கல. That is the problem. That's why that question was ignored. Okay, chalo. Let me drop the next question. 1 minute. Yes, so the given question is there is one resistor and there is one inductor. This is supply voltage. What they told is the voltage across the inductive coil. They clearly told with the polarity it is VL. And resistance value is 17.32 ohm. Sorry. 17.32 ohm. 17.32 ohm. Okay, that is the resistance value. And supply voltage is Vs. That is given. Now the question is, in the given circuit, the voltage VL as the phase angle of dash with respect to supply voltage. What is the phase angle difference between inductive voltage and supply voltage? That is the question. And this inductive reactance value is given as J10 ohm. in the given circuit, the voltage VL has a phase angle of dash with respect to supply voltage. Inductive voltage வந்து supply voltage இருந்து எவ்வளவு தூரம் lag இருக்கும் அப்படிங்கிறது தான் question. Lagging or leading, I don't know actually. We have to draw the phasor diagram for that. அதெல்லாம் தேவையில்ல, just apply your common sense. Inductor voltageக்கும் supply voltageக்கும் phase angle எவ்வளவு வரும்னு கேக்குறாங்க. Just do it and tell me the answer. Do it fast. Anyone got the answer? Take your time. Got the answer? No one? Try. Sukumari 30 degree, Chitra Devi 30 degree. Very good. Any other? Got the answer? All of you, Kanaga, Savita, Rajesh, good. All of you are getting 1:4. Take the next question. Find the active and reactive power, that is real and imaginary powers from the given data. Here the question is total impedance is that in S dash. Don't think about this dot at all. That things we will discuss later. Just to calculate the total impedance in this question. in this question. Value of C is dash when the total power factor offered by the circuit will become 1, that is unity. Value of the capacitor is dash when the total power factor offered by the circuit will become unity. Okay, now these are all your homework question. Start from the first question. Don't drop your solution at any cost in the group. First thing. Second thing, don't refer any textbook. You all know this is previous year questions only. You can find the solution somewhere by someone. நீங்க மாஸ்டர் ஆகணும் அப்படின்னா உங்க பிரைனை தான் யூஸ் பண்ணணும். யூ நோ தி பேசிக், எல்லாத்தையும் கிளியராக டீச் பண்ணியிருக்கேன். இன்னொரு டைம் வேணால் ஏசி சர்க்கியூட்ஸ் நம்ம நடத்துகிற எல்லாத்தையும் ஒரு டைம் பாருங்கள், திரும்பவும் பேசிக்ஸை மட்டும் அப்ளை பண்ணுங்கள். ட்ரை டு பிரிங் தி ஆன்சர் பை யுவர் ஓன். கரெக்ட் யுவர் சொல்யூஷன்ஸ். எனிவே நான் டுமாரோ ஐ எம் கோயிங் டு சால்வ் ஆல் திஸ் கொஷின். Compare your solution with my solution. What is wrong in this? What mistake I have done? Just think in that way, rectify the mistake. Okay. So question என்னென்ன கேட்டிருக்காங்க அப்படின்னா, first question நம்ம சொல்லியாச்சு ஆல்ரெடி. Second question, calculate the real and reactive power from the voltage and the current. Then in the third question, calculate the total input impedance from the source. Fourth question, calculate the value of capacitor when the power factor offered by the total circuit will become unity. That is the total. Okay, try it by yourself. I am repeating again. Groupல ஆன்சரை மட்டும் போடுங்க, போட்டு கம்பேர் பண்ணுங்க. மற்றவங்களுக்கு அதே ஆன்சர் வந்திருக்கா இல்லை நமக்கு வேற வந்திருக்கான்ட்டு. That's all. You no need to do anything apart from that. Rest of things we will see in the next